Okay, I'd like to welcome our next speakers to come up to the stage. Jeremy Febus and Mark Gray are going to talk about cleaning stormwater at the center of the universe. So, gentlemen, take it away.
Good afternoon. Happy Earth Day. Thank you, Phil, and thank you, Seattle University, for hosting us. We're happy to be here and excited to talk to you about some of what we've been up to the last 10 years. I'm Mark Gray. I'm a principal with Stephen Gray and Associates. We're a property management firm located in Wallingford in Fremont area. And then I'm also a partner with Hess Callahan Gray Group. We're a developer that's really focused at kind of in that Fremont area and whatnot. And this is my partner in crime, Jeremy Febus. He's a civil engineer with KPFF. And about 8 years ago or so, we started a nonprofit called Clean Lake Union. And we're going to talk a little bit about Clean Lake Union, what we've been doing in Fremont, and then really Fremont is known as the center of the universe. There's naked bike riding there and whatnot. And from the Solstice Parade, it's a pretty eclectic area. And we've been doing some things there over the last couple of years. So we're going to talk about that today. Here's a little bit Troll Avenue. That's right. That's ground zero for us. And so Jeremy and I, like I said, we've been talking together and working together for over 10 years now. We got started on a project and we're wondering what we could do in the city of Seattle at the time that this photo was taken. What is this, July 2017? That's Seattle, just what, 7 years ago, 8 years ago? There was a lot of cranes and a lot of development. And as I mentioned, I'm in the development industry, born and raised in Seattle. My dad went to Roosevelt, my wife and I went to Roosevelt. I have 4 kids who've all gone to Roosevelt High School. So we've been in this area for a long time now. And we wanted to know what could we do to make a difference here in Seattle. This is right by my office. There's a marina there and you can see the oil slick in the water. And as part of running that marina, we have to have a best marina management plan. And we saw that oil on the water and we're like, what is going on? Where did this come from? Get our spill kits out. We thought an engine was leaking. And we came to find out that it wasn't an engine leaking, it was stormwater. And really, I mean, this is as simple as it gets, but you can see the storm.
It was doing what it was supposed to.
Yeah,
Unfortunately.
Yeah, there's no filtration in these stormwater systems, but this drain right by the office, you can see the oil slick going into the drain, and then you can see the water in the background. That's the oil slick from that water. With all the development going on, we knew that there was a problem. Jeremy, this is back in 2013, probably 2012, said, hey, Mark, you should look at this video. Jen McIntyre, she's a professor at Wazoo. And they were, the video, without going into the video, they were taking stormwater off the 520 bridge and sticking juvenile salmon in that stormwater. And the salmon would die within minutes, just because how much toxic material is in that stormwater. And so Jeremy said, what can we do about this? And this is an email from Jeremy to me, October 28th, 2014. And it just says, I know it might be a long shot, but please send me a photo of any dimensions. And Seattle also has in addition to a stormwater problem, combined sewer overflow. So our pipes in the city of Seattle are really old, 80, 100 years old, and they haven't changed. And you saw those cranes, we've added a lot more development. So there's a lot more sewage going into those pipes, right? Same, and when they're combined with stormwater, you've got a problem. And so in our development project, this is that water tower that we were talking about. We were going to build a building and cut off the legs of this water tower that was going to be demolished, paint the top of this thing pink, put it right next to the Aurora Bridge, and hold the stormwater coming off the Aurora Bridge in this tank. While it rained really heavy, right, that overflow water that's what makes sewage go into Lake Union, right? Because our pipe is the same size. The rainfall's pretty consistent. We've added all this development. So when you add the sewage and the stormwater together, it overflows into our lake. And so our thought process was, let's take this tank and making it a holding tank. So when it's raining really heavy in Seattle, we'll hold the stormwater in here, allowing the sewage to do its thing normally. And then when it stopped raining, we would release that water out. We were going to paint it bright pink and put it in our building and say, crap happens, ... but not in Fremont, and count how many gallons of sewage we prevented going into the lake. So this This led to a bigger problem. The property we were looking at was not a combined sewer overflow area. The pipe is just stormwater. And Jeremy said, hey, this is actually not a bad thing because the bigger problem is actually stormwater, which Jeremy is going to talk about now.
Yeah, it's I think it's intuitive to a lot of people like that when sewage systems overflow into our waterways, that's a bad thing. And so Seattle has been able to rally resources and improvements to improving our combined sewer overflow situation. It's a little less intuitive, but arguably substantially more consequential. The untreated and polluted urban stormwater runoff from our roadways and waterways that goes into our into all of the water around us, not just this corridor, but this is one we focused on initially.
I don't know if this has this pointer here, but we're right here in Fremont. And so this red area is all the stormwater that flows downhill into Lake Union. And you think about the salmon migrating through the locks, this is a pretty small body of water that they have to run through to get to the rivers where they do their thing.
Yeah, that's a great point here, Mark, that this is a this really captures that this is the tailwater of like a 3,000 acre basin of the Sammamish River, Lake Washington watersheds. So every single salmon in those watersheds has to run this gauntlet through here. And then you consider too that the challenge with urban stormwater runoff is salmon in the Puget Sound are running in September generally, right? Late August, early October, depending on the species of salmon. And when does Seattle get its first kind of heavy rains each year? Usually late September. And so you have sometimes 30, sometimes 60 days of soot and sediment and rubber and heavy metals accumulated on the roadways. You get that first heavy rain in third week of September, fourth week of September. It's all going out these red points on here all around Lake Union and the Ship Canal. There's hundreds more on the Duwamish and around Elliott Bay, Lake Washington. The purple sites are combined sewer overflow locations. So again, just to highlight there's a reason why Puget Sound resident orcas have the highest blood toxicity of any mammal in the planet because they're eating all of the food out of these corridors. There's a reason why salmon mortality is so high in the Puget Sound waterways. So just to emphasize that a little more, so this is actually on the street that we're going to focus on here on Troll Avenue. If you've walked down the street from the Troll there, you've maybe noticed, the civil engineers in the room might have noticed the pipes coming down the columns and that just dump right into the curb, just literally like you see right there. And that cup of water is literally just held right under that downspout right there. That's a normal, it wasn't even like a first flush. That was just a.
All of you can do the same test. Just take a coffee cup, stick it underneath that downspout. That's located at 34th and Troll Avenue. And that's what the water looks like. And that water goes straight into the lake. There's no filtration. That's the water going in.
And Salmon Safe did some actual water quality testing of the material and then of the water we were getting off of these downspouts and then benchmarked it to I-5, to Highway 520 and to California state averages. And there are a number of theories why, and we won't go into kind of trying to explain why, but for whatever reason, so the Aurora Bridge are the green bars on there. So the Aurora Bridge tests consistently higher on most of the measured contaminants than each of those benchmarks.
So this is one of our first project. This is back in that 2012 timeframe when we started looking. And so this was the site. Here's the Aurora Bridge. Here's the canal right here. The outfall is right here for all this stormwater that comes out. And this was a rendering of the building. You might, if you've been to Milstead Coffee in Fremont, Just Pokey's there, Cafe Turco. So this is the right of way right there. And so what we did is we have slope here. And so we put in a series of bioswales. Again, you can see the water in the background. What's interesting about this, and people would say, hey, how do you do this? How does this work? what's really interesting is we're taking water off a state freeway and then taking that water and cleaning it into city right away, and then cleaning that water, discharging it back out into the same city system, and then back out into the lake. So to make this happen legally, it required, so if there's any attorneys in the room, the state attorneys and the city attorneys and the Department of Fish and Wildlife was like, you can't do this. A private developer can't take the water and put it onto private property and clean it. And so what we ended up doing is we built all of this and gave it back to the city. But this was just an asphalt area. This was a dangerous area. There's graffiti here, lots of things. This is now, you'll see here in a few slides, this is all improved. And so here's the finished building. And here's the bioswales that were installed. And again, I'm going through this pretty fast, but so this is, we took the downspout off of this column right here, and it goes underground, outflows here, goes cascades down through, and then comes out through this downspout. That's the before water, similar to what Jeremy just showed you. And then coming out the second, that's what it looks like after going through one bioswale. Pretty cool. And what I love about this is, a 5-year-old gets it. This isn't complicated science. Nature's doing its job. And so we have a series of 7 bioswales. The water very rarely gets to the bottom, meaning nature's doing its job. And this building went online in 2017, and we've had to change the sellout once of the soil. So really exciting stuff. And so again, here's a same thing, the completed bioswales all along here. And this is city property. And then visually, again, here's the Ore Bridge. That one downspout captures this much stormwater, right? So I think everyone can nod their heads and say, well, there's a lot more opportunity to capture more stormwater off this bridge. And that's what we did. And Jeremy's going to talk about it. Oh, here, I'll skip over this. It was pretty exciting that after we did this first test, we got a lot of positive feedback. That was the Puget Sound Partnership that did a study on it. Someone from the EPA saying, I want to do a study on it. We were really excited about the momentum we had. And so we built another building across the street, which Jeremy is going to talk about now.
Yeah, so Mark calls and says, we're looking at the property across the street. We were only able to get one downspout, and it was like an unprecedented kind of move there. Mark kind of breezed over it, but there are almost no developers in Seattle saying, how can I volunteer to treat 100-year-old pollution problems in the city? So we've got development across the street that Mark's looking at, and now we're excited. We've proven it can work, and we want to go bigger. So on the development, on the building side, on the vertical side, the architect team and Mark's ownership team, like this is the living building pilot project, water reuse, light adjusting, windows, just everything you could think of, kind of how can we make this the greenest building possible. But on the stormwater side, we were looking at the same situation, finding, here we could hit 2 downspouts. We could capture twice as much water as we did on the opposite side.
Here's that same look. So the 2 downspouts, again, we're capturing more of the Ore Bridge and that contaminated water.
So like Mark was saying earlier, if any of you can remember back here, this was a difficult area under the bridge here. Was dark, all asphalt or concrete. Now it's in a vibrant urban park-like boulevard with urban nature and green space kind of brought into the city. You could see, I mentioned they did everything on that building, even bees on the roof, and you could, all the finished green space and those same level pools kind of stepping down the hill, and the water recirculates between each one now on both sides of Troll Avenue. And then we said, why stop there? So phase 3, so Mark happened to also be the property manager for a large kind of corporate collection of corporate campuses down on the south side of 34th. So that's the Burke-Gilman Trail on the right, kind of sweeping under the bridge there. A number of you have probably been down through there, but it looks different now. And this was kind of an inspiration. We were Mark mentioned a lot of the gymnastics of trying to get through a wide range of regulatory agencies to do some of these things. One of the challenges was competing land uses and the perception that you can't have recreation and technical stormwater landscape together. It just that they don't work together. One precludes the other. And so, and kind of an inspirational project that we held up a number of times was the Tanner Springs Park in the Pearl District in Portland. And then with all the excitement that had been generated by this time, the UW Landscape and Architectural School actually made this like a senior project for one of their classes and went through and did a wide range of different landscape possibilities for how we would duplicate this under the bridge.
These are all different designs from University of Washington students.
Okay, so phase 3, now this was a much bigger move because down here we could capture 5 downspouts. So we mentioned 1 on phase 1, 2 on phase 2, and then we could capture 5 more on phase 3. And so and what you'll see here in a minute is we carve away this turf hilltop that's there. This is us meeting out there with a series of state senators and representatives and local politicians talking about how to raise money for this. And under the governor's Orca recovery initiative, this was one of the first projects funded. We got $500,000 from the state to help build this thing. And now if you go out there and hopefully if you've maybe seen it from the Burke-Gilman, where this can treat 1.5, 2 million gallons of stormwater annually. This is a dispersion trench that flows water across the whole facility there. A project that Mark will talk about here in a minute that's kind of what we call phase 4. This is a cross-laminated timber CLT bridge that was donated by that project to kind of create additional park and amenity space integrated with the stormwater mitigation here. And now you can see combined, we're treating close to 2 million gallons of runoff with all roof down or with all bridge downspouts combined here.
What's exciting is, I mean, this is a bridge, right? There's bridges all over the world. So this is a replicable concept. And what we're going to show in the next phase is just that it doesn't have to be related to a bridge, but I-5 is amazingly dirty, and all that water from basically I-5, the water from Green Lake all the way to 45th outfalls right there by Ivers on Lake Union. And that's a lot of stormwater. So this, just driving home the point, this is the tribe. They annually put a gill net out right here in the fall. And Jeremy said that first flush. So think about it. Our roads are dry all summer long, and that first rain happens in September. Guess when our salmon are migrating? Right? So the salmon are running right through here, and this is only here for about 3 weeks, and that's the water that's coming out. That outfalls right next to this net, which is sad. And so here's the locks. This is public data, but this is just how many salmon have come through the locks annually. But you can look back at 2006, we were 453,000. And I was talking to someone recently that was looking at it and said, these numbers are a little bit off because a lot of the salmon are getting into the lake, and the Lake Union is so warm that they're turning around. They're not even making it to the river. Again, the little asterisk next to that. This is phase 4 that Jeremy was just mentioned. This is North Lake Commons. It just got completed here in the last 2 months. This is right by Ivers. I'm going to speed up because I think we're getting short on time. But what we did here is we took the neighborhood stormwater, and here's the site. And all the water that hits this area outfalls right here, and we put in a bioswale. So the water normally would come down this track right here and straight into the lake, and we installed a shutoff. And so the plants are just maturing right now. As I mentioned, the building just got done, but we're going to let them kind of mature throughout the summer. And then probably in July or August, we'll do the shutoff and route the water onto our property and clean it through a bioswale and then discharge it back into the same city system that previously existed. So what's unique about these 4 different phases is, the first 2 were done privately, but on city property. The third phase, we got state money, and the Boeing Foundation got involved, Adobe got involved, and we raised money and built that one. And then this fourth phase was done privately, but we worked really closely with Seattle Public Utilities. And because the city needs to clean their water as well, the city is giving us a six-figure check to do the stormwater cleaning on this property. And why did they do that? Because the reason is this is private property and we're putting their systems now on private property. But it's really cool to see the partnership take off, and Jeremy's working with another developer that's now doing it, which is the best compliment we could have is more people are starting to do this. That's all we have. There's a lot more. I put this ending slide kind of halfway through the presentation. But I should mention too, you can see CLU, Clean Lake Union. Jeremy and I, as in part of this, right after we did that first phase, we started a nonprofit called Clean Lake Union. We do a paddleboard race annually to raise awareness. We start kind of in that same area where that first building is, rent paddleboards and go to Kenmore, Air and back, and then just raise money. So if any of you wanted to get involved, we'd love to hear from you and come down and support the race. And then there are smaller versions of this. Again, we have a whole nother deck behind this where you can do that first. We're in for permit at that first where I said like it started, that aha moment. We're going to put a bioswale right there on a waterway 17, I think it is. Yeah, Eastern Avenue street end. So there are opportunities to do smaller scale of this as well and go bigger and go worldwide. So thank you for having us. Happy Earth Day. And I think we have time for questions, Phil. Is that right?
Yeah, I think so. Thanks,
Yeah.
Mark and Jeremy. And I know we talked about maybe getting some Seattle University students involved with the first flush sampling this summer. But how about any questions from the audience? I can run around and do here we go.
Hi, my senior design team is working on designing bioswales for a parking lot that has like stormwater runoff. And we did some research on a contaminant called 6-PPDQ, which is runoff from like from like tires and is highly toxic to salmon. Have you done any research into that?
Yeah, so the 6-PPD, it's kind of a latest and greatest science. About a year ago, actually, Jen McIntyre that Mark mentioned was one of the key researchers in identifying that one of the main culprits in salmon mortality and urban runoff is a particle called 6-PPD, which is a part of rubber used in tires. And so there's a lot of that. And so just the general wear of tires on our urban streets is causing this particle to enter our waterways. There is the regulatory guidelines do not yet address the 6-PPD, but research at this point shows that green stormwater systems like bioretention actually do remove it. More proprietary systems that are also in wide use have not shown to remove it. It doesn't mean they don't, they just haven't proven that they do, but the type of systems that you're talking about employing do seem to remove 6-PPD.
Thank you.
Yeah, so tires are a big problem. That's the big aha moment, and more research is being done on it right now.
We got one more question over here. The students aren't old enough to know who Phil Donahue is, but I'm going to walk over here with my Phil Donahue.
Your first stage of the bioswale, the
Yes.
plants, would they be killed by the runoff? And do you need to replace the soil and plant?
Yeah, so I mentioned that. So that project started went online 2017, and we've had some plants that need to fail, that would need to be replaced and failed, but for the most part, really low maintenance. We did some soil replacement in the first cell only. We haven't done it on the way down, and then same thing on those other two phases. Again, when we made the pitch to that owners association that Jeremy was talking about, it was grass, and we had all the weekly mowing expenses and all that. We don't have that anymore. So it was really exciting to see that it's a pretty low maintenance solution, and it doesn't need as much replacement as you might think.
Mark and Jeremy, thank you so much for your presentation today. How about a
Thank
big
you.
hand?